Hello and welcome back. In the last segment we added some dialogues to the bowling scores application, and we're kind of adding in that case to the usability, but we didn't yet persist the data. So when you run the application and you type in your scores, it doesn't really make any sense that those aren't there when you go back to do it again, because the whole point of it is to keep the history of the bowling scores. So in this segment we're going to take the opportunity to introduce talking to databases from Android, and the database that's built into the Android API is called SQLite. Some people say SQLite, but I think the correct way is to say SQLite. So SQLite is used in many other places. It's an open source small database program that's written in C, and it is an ANSI SQL compliant database. So if you have some database background, this is going to be familiar to you, but if you don't, it doesn't matter. We're going to just do simple things, and you'll learn a little bit about database as we go along in this form. So it's not a database course, and we're not going to look at here's how you do all of the possible things that you can do in SQL. We're going to do some pretty simple stuff. We're going to create a one table database on the Android device. It's called a private database. That means that only this application can see it, and we will update it. We'll add bowling scores to the database, and we will retrieve them. In this segment we won't do any deleting. So we only have one activity in the application so far where you enter the scores, and as of now they go into an array list. Well, we need them not only to go into the array list, but to go into a persistent data storage on the device so that the application can load that data when it's run the next time. So there are two classes that we'll use that make it somewhat easy to interact with the database. One is called the SQLite database. That's the actual database object that we're aiming at, but we'll use the SQLite Open Helper class to get started with that, and it helps us, well, you'll see, it helps us get a database onto the device. So we're going to make a very simple database with one table, and this is kind of what it looks like. So the primary key, each record in the database must have a primary key so that we can identify this as a unique record. And we'll ask the database to generate those for us. So as we add a record to the database, a set of bowling scores with a date, the database will generate a unique number, an integer number that hasn't been used before, and that's automatic. And I think all databases do this for us if you set it up that way. If you say, I want you to generate the ID of the record, then you just let it do that, do the work itself, and then get back that unique identifier. So the calculated values, like the sum of the three games and the average, the running average, we're not going to put those into the database. Calculated values can be well, calculated on the fly based on the data that we have. So we're going to call this table the bowling scores table, no surprise, and it has 5 fields, and the fields have to have a name, and they have to have a data type. So in this slide I'm showing the data type of the date field as a date, apparently, and along the way I change this, and we use an integer here, actually a long number, to store the date. And I'm a little bit frustrated with manipulating dates, and that's kind of common among people who work in Java and databases in general. How do you store the date? There's any number of different ways, and different classes within the Java API handle dates in different ways, and then the database wants to handle it in a different way again. So there's a sticking point there, and I'll show you how I got around that. I'm not convinced that it's exactly the right way of doing it, but it is a way that is pretty much guaranteed to work. Okay, so here's what we're going to do when we go into the code. We're going to create the database file on the device and the data structure. So there's a fairly easy way of using the helper class to create the file on the device. And we will actually go into the device using the DDMS and look at where that file is, so that you're kind of comfortable that there is physically a file on the device in a private area that only our application can look at. And then we will add the data to the database as the user enters it. So when someone enters their bowling scores, we are going to add it to the array list, and we're also going to add it to the database. Then when we're done that, when we can get data into the database, we'll go and look at how to, when the application starts up, open the database and get all of the data that's in there and put it in the array list. So when the user starts the application, their data will be in a state that's the same as when they left it the last time. That's kind of the data persistence, the whole data persistence concept thing. So the array list and the database will have the same data in it all the time that the app is running. And when the app isn't running, there's no such thing as an array list. There's only the database sitting on the device waiting for the app to start again and load all the data into the array list. So 3 of the 4 we're going to create, and we're going to update, and we're going to retrieve. We don't have any way as of right now to delete data. So if you have a bowling score from 5 years ago and you're not interested in keeping that in your database anymore, there needs to be a way to delete that, and we will put that in our other activity. So this is where we left off. We have the application that includes the dialogues, so it will tell us if we're entering something that's over 300, and we can actually change the date there, and we looked at how to retrieve that information and put all of that one record of data into the array list. So let's start dealing with the database issues. So the first thing that we're going to do is go to our source directory and add a new class, and this class I'm going to call it Bowling Scores Database Helper. So it's a long name. Bowling Scores Database Helper. And the interesting part of this is that it inherits from SQLite Open Helper. We don't have a path for that, so I'm going to do a control space, and it runs around and finds the right one for us to be inheriting from. What method stubs would you like to create? The inherited abstract methods. So let's see what we get when we do that. Okay, so we have a new class, and there are 2 methods already in it. These are the ones that we are required to override. And it says it's not compiling, that it wants a constructor. Yes, okay, let's give it a constructor, allow it to add the constructor. And so this is something, this whole video actually is going to go fairly quickly, but it took me a couple of days of digging around. So how do I use this SQLite Open Helper? And it turns out that there's a lot of this constructor that I don't need. I do need it to have a context, but nothing else. And we're going to call the constructor of the parent class with the name of the database, and I'll just type in a string here. So I'm going to put my bowling scores dot SQLite. There's no convention that I can find of exactly what the extension on these files should be. Some people are using .db and some people are using .SQLite. I thought that that was more descriptive, but it doesn't seem to matter. And we don't need this at all, but we have to pass in something, so we'll pass in null. And the version number. This it keeps track of the version number of your database so that if you change it, if you have another release of your product, you can go and you can check on what version it is that the database is in, and then you can upgrade it somehow. And this is done kind of automatically for you. So I'm going to say that this is for us version 1. And if we ever have a release and we need to upgrade to a new version of our database, this method will get called automatically. And it will, well, we put code in here to decide what to do. If the structure of the database changes, we have to get the data out of the old one, restructure it, and put it into the new one. So that's what this on upgrade is all about, and it corresponds to this version number. Everything is compiling in here now, and I'm going to use what people would refer to as a best practice. If you leave strings kicking around in your text, hard-coded in your code, people will frown at that. So you should define some constants at the top. So I'm going to make a public static final string, and I'm going to call it dbName. This is the name of the actual file that's going to be put on the device. So I'll take that string that I typed in because it looked easier at the time, and I'll put it up here. So now anytime that we need the name of the database, we're going to just use this identifier instead of the actual string. And we'll do that all along as we go along. In fact, I'm going to not allow the version to be hard-coded here. I'm going to call that db version. And that means that I need to, I wonder if it will help me with this. Create a field db version. Let's change it to public. And we're going to make it a final. And we will assign it to 1. So now whenever we want the version, we'll refer to this identifier. So far so good? Okay, so here's the interesting one. When someone wants to create a database, that means they want to create this file on the device. This method will get called. So if that file is not there already, the onCreate method will automatically get called if someone tries to create one of these databases. So the onCreate method in this helper class is where we're going to put the code to create the database, including its structure. That means how many fields does the database table have? How many tables does it have? How many fields does the table have? What is the name and the data type of the fields? And it sounds complicated, but it really isn't. It's a big SQL statement to create the database. And I'll just type it and we'll then look at it and see how it goes. Okay, so don't freak out. It's not as hard as it looks. We have tightened that up a little bit. All of this is one statement, and it's to create a string, which is a SQL statement. It's the SQL command that we're going to execute. So inside of the quotes, we're saying that this command or this SQL statement starts out create table, and the name of the table is going to be bowling scores table, and I've defined that as a constant string up here. Bowling scores table. Don't put any spaces in here. That's going to be an identifier, a SQL identifier. Now, the characteristics of the bowling score table are here between this parentheses and this parentheses. So, the fields in the bowling scores table, maybe I could put a carriage return there. There are 5 fields. This is where we're defining the table. And the first field is the ID of the record. It's an integer, it's the primary key, it's auto increment, and it's not null. So all of these are kind of switches to SQL to tell the SQLite database how to treat this field. And understanding exactly what all of these mean, at this point you either do or you don't. But when you're making this string, the SQL statement string, I can tell you that I lost a whole lot of hours because I didn't get the syntax of the SQL statement correct. So a space here and a comma here. So inside of these parentheses, we're working with the syntax of SQLite. And this is a well-known problem for anyone who generates string SQL commands, that this compiles because it's nothing in Java world, it's nothing but a big string object. But in the SQL world, if that space is not there, it's not going to work as a SQL statement, a SQL command. And these commas, I had left one of those out when I was getting this working, and it really didn't tell me much of what was going on. So I defined these public static strings so that if we ever need to know, and we're not in here, if we ever need to know the name of the field, we won't access it by trying to get the spelling of it right there as the string. We will access it through these constants. And that makes things easier. Eclipse will help you by, when you type that dot, it pops up what the possible things are. And we want these things to be popping up. We don't just want to hard code in the actual strings into this big string. So it's not that hard really. All we did was we made one SQL statement and we defined some constants. The hardest part of this might be understanding that it's the primary key and it's going to auto increment. That means that it's going to generate them for us and they're going to be unique. So whatever the biggest one is in there, when we add another record, it's going to give a number for that ID as one bigger than the last one. Okay, so be pretty careful typing that, and because this is complicated enough that it probably won't work the first time, I'm going to log that string. Let's see, we'll call the debug method in log, and we'll tag it with bowling database, so it's easy to find in the as the log items are going by. Well, why don't we just put the SQL statement there? We'll know what it means. The SQL statement is a string object, and I'll just throw that string object into the log so that we can look at it if something doesn't work the way we want it to. This one will work if you manage to type it exactly like this. And I can tell you that if it doesn't work, that's what happened to me. So I did have to fool around with this, and I had to dig around in the syntax of the SQL statements for a little while. Oh, okay. This generated an arg0 here. That's not a very good name, is it? So I want to call our SQLite database. I want to give it a reasonable name, so I'm going to call it the bowling scores database. So that's a Java object of type SQLite database, which gets passed to here, and you don't know where that's going to happen yet. So after we create that SQL statement, we have to execute it. And we're going to execute it from the bowling scores database object. So there is an exec SQL and we're going to pass in the SQL statement, which is that big string that we just created. Okay, that's really all there is to it. So this class that we've created, we haven't made an instance of it yet or done anything. This is all just to set up how we will use an instance of this helper from our application. So what we are going to do next is go into the application. Do you remember the application? This is kind of the highest level where we have the array list, and this is the life cycle of the application when the application is created, and we're going to make an instance of our bowling scores database helper, and we'll do some of the stuff in here. So as soon as the application is created, that means that it just starts running on the device. We're going to make an instance of bowling scores database helper. I'll call it database helper. Let's make one of those. And it needs a context. So the context for it will be this, the application that we're in. What else do we need to do? Almost nothing. We need to declare application-wide. Well, let's let Eclipse help us with that. The bowling scores database itself, the object that represents the database, comes from calling the database helper get writable database. We could get a hold of the database for reading only, but we're going to put stuff in it. So the only thing that we don't have is we don't have this guy declared, and we're going to create a field, and it even knew that I wanted this to be a SQLite database. Okay, so the first time you run the application, when you have never yet run the application where it creates the database, like when we run it this time, we're going to ask for the writable database. It will detect that we have never created one, and the database helper will execute this method, the onCreate method, and it will drop the database called MyBowlingScores SQLite onto the device. Now that only happens the very first time, because if you ask for the writable database, the next time you run the application, if it's already on the device, of course it's not going to go and create a new file and clobber your old one. So here's the tricky part. If there's a mistake, You've created the database file, but then if you go back and change this, it doesn't matter because it doesn't get called anymore. So here's what we're going to do. We're going to run the application. It doesn't actually put anything in the database, but it creates the database with that table, the structure of the table, and it will drop that file, the SQLite file, into the device. I want to make sure that that's working. So let's do that now. Let's run the application. It has stopped unexpectedly. Please try again. That's not good news, is it? So that happens to me sometimes. What should I have done? Let's get some help going on here. Let's look in the DDMS. So if we run the application in here, we'll get to see the log. We should also have a console window available to us. Let's get a console window. Okay, so we're expecting that something is going to happen. It's installing it. Now it's starting the activity. Nothing is blown up yet. Until we go and try and show it. Interesting. Nothing is in the log. What do we do now? Let's start debugging. So, very early, I'm suspecting, since this was working before, that it has something to do with making the database helper. So I'll set a breakpoint there, click on the bug, wait for a while. Okay, we have hit the breakpoint already. So I'm going to step into the constructor of the bowling scores database helper. Here's my step into. This often happens. When you try and step into a class that hasn't been used before, you step into the class loader. So here's what you can do. Step out and then step in again. So now we can assume that the class has been loaded. So we're making one of these. While I'm in here, I'm going to set a breakpoint in the onCreate method to see if we're hitting that. So we're going to execute the parent constructor. Now when we call getWritable_database, that should take us to the onCreate method. And it did. So we're making this SQL string. And then we're putting something in the log. See, I thought that wasn't working before. Why isn't it in the log? Oh, here it is. Create table, bowling scores table. So ID. I'm not seeing anything wrong with that. And if we execute that statement to create the table, is that the one that's going wrong? Oh my. Let's hit the resume and see what happens. Stuck. Okay, an exception. Yeah. Duplicate column. Here's the clue. We finally found something that makes sense. Duplicate column name game 1. Okay, so there's something, I did a cut and paste of the 3 games, and yep, didn't go and change them to game 2 and game 3. Isn't that something? I hope you're all sitting there screaming at me. So the process, when something goes wrong in these SQL statements, this turns out to be a fairly valuable thing. Lots of logging, and look in the DDMS to try and look for clues to see what's going on in the log. The Android API itself dumps a lot of stuff into the log. Most of it at this point I don't understand, but there's clues in there sometimes, and we found a clue to that particular problem. So I hope that you all didn't make, that's my new southern accent, you all didn't make that same mistake. Okay, in the DDMS, while we're here, look in the File Explorer tab. We have a folder called Data. And under there we have another folder called Data. So this is data that belongs to specific processes. Down here, it has created for us a folder called Com Valencia Programmers My Bowling Scores. So that is the application, and it has a folder called Databases, and now it has the actual database itself, My Bowling Scores SQLite. We're now in exactly the problem where I was talking about before. There is no way to run that code again because the onCreate method will never get called, because this database already exists here, but it's got a mistake in it. So this is a hard place to get out if you don't know how to find that file. So in the File Explorer in DDMS, under Data, Data, the folder that belongs to you, and now we want to get rid of that. You can actually take it, a copy of it, pull it off the device and put it on your machine and look at it. And I had to do that a few times, but we could also use this red thing and delete that guy from there. Now, he didn't delete. What happened? Oh, maybe it just took that long. Okay, it just took that long. So now, assuming that assuming that was the only thing that went wrong, we should be able to run this again. And I'm going to run it without the debugger just to see what happens. But I do need the console. Where is my console? Okay, so my enter scores activity has started. Thank goodness. Okay, so we what have we achieved so far? We have created a database. We haven't put anything in it yet. Let's go and look at that now. In the application, we have now a writable database object. That's the key guy. Before, what we were doing is we made an array list, and what we're going to need to do eventually, I'll just put a comment in here, maybe a to-do, and we will say get the data out of the database. So as soon as the application starts on create, we're going to go and fetch the data out of the database, the history, bowling scores. But we'll save that task for later. Down here, where we call add bowling scores, so as soon as the user has entered the data and we've validated it, we created a bowling scores object, we're going to then add the scores to the database. So this was adding it to the array list, and we're still going to do that, but we're going to add it to the database first. We have another kind of a helper class called content values. Content. It's only going to be used locally, so I think I can get away with calling this a CV. And this is a way of making an object to help us insert something into the database. So a great huge string of stuff is kind of hard to get it right. We saw that. So we're going to use this class to create the, I guess it's the object that will put the data into the database. And it can't find it, so let's hover over it and say import content values. So what we do is we make some pairs, some key value pairs, and the key is the database field, and the value is what we want to go into that database field. So we have a constant for these, so bowling scores database helper dot, what constant do we want? The date, and what value do we want in that field of the database. So we're getting ready to insert a record into the database. We're going to take that object that was passed in, bowling scores, and we're going to get the date. Now, there's a problem with that, but I'll fix it later. I'll put a message there to use epic. And I wonder if that doesn't compile. It wants string string. I don't think it wants string string. It's happy with string int. Okay, so the problem that I have to fix later has to do with that, and I'll just keep doing this. I'll add the other ones which do work. So we're going to put bowling scores database helper game 1, and the value for that is bowling scores get game 1, and see if we can do the copy and paste without making any mistakes this time, because we've got 3 of those and we want to put game 2 there and game 3 there, and in the constants we have the same thing. So those are the names of the field in the database, and those are the values that are going into that field. And then we're going to insert that record into the database. So the insert as a SQL statement is really is very complicated with all of those issues of the double quotes and the spaces and the commas. And that's the purpose of setting up this content values thing, so that it helps us to generate the SQL statement. And it is kind of helpful. I'll go ahead and finish this part. Before let's log stuff. So before inserting a record, and I'm going to concatenate together the bowling scores object so that that will appear in the log, and that might help us later on finding out something that's going wrong. Okay, so we've done some defensive programming there, and we will say, let's take the database and insert into which table do we want? Well, we have defined a constant for it. The table is called bowling scores control space, see if I can get some help, database helper dot bowling scores table. That's the name of the table. And this second argument, I'm not sure that I fully understand, a column hack, but we're going to be able to pass a null there. Did I hit caps lock someplace? And the values, we're going to pass in that content values object that we made up here. And there's one more thing. This insert statement will give us back the ID that it generated for this record. So remember that I told you, as we put the records into the table, there's a primary key. And the primary key for the record is generated when you insert the record. We need that number. So I'm going to say along the ID passed back. We need that number, and I'll tell you why in a minute. So this is done, but it's not yet working. It's not working for two reasons. We have this issue with the date, and we also have the ID issue. We have to do something with that ID. So here's what we're going to do. We're going to go back into the bowling scores object, and we have to do some stuff in here. The first thing what we're going to do is we're going to add an instance variable that represents the ID that it has in the database. I think we should use, let's use long and call it ID, and then we will generate getters and setters for it. And you might be screaming about that we're breaking some rules here. And I'm going to initialize that to, no, you don't need to initialize it to 0. It will anyway, that's the default. So this is kind of a compromise. In object-oriented design, bowling scores has a game 1, bowling scores has a game 2. Now bowling scores has a ID. Well, not in the real world. When you picture some bowling scores, there is no database ID associated with it. So this is kind of stepping outside of the ideal object-oriented design. And what some people will do is make a parent class for this class called something like database item. So a bowling scores is a database item, and they put the database ID in that parent class, and that preserves the object-oriented design. It's a little bit more complicated, so I'm compromising this one here so that we won't have a parent class on bowling scores. It just has an ID, which is an integer number, a big integer number maybe, and that's going to be generated by the insert command. So let's go back here where we did the insert command. What did we insert? We inserted this bowling scores object. So I want to take that guy, the object that was created when the user entered the data, and set its ID to the ID passed back from the database. And this adds the bowling scores object to the array list. So let's just go over that for a second. When the user has entered some bowling scores, we create an object of type bowling scores, and we say we want to add it. And before that meant we just add it to an array list, but now it means we create one of these objects and we add it to the database by making an insert statement and executing that. Well, this actually does the execution of the insert using this contents values. Now, we still have one issue, and this one I'm really kind of not happy about. A lot of databases have a data type called date, and you can just kind of pass dates into it and it stores them, and SQLite has a very strange way of handling dates, and in fact it's kind of ugly. So here's the SQLite data site, website. You can dig around in here and find out how they handle dates. It turns out, I'll just give you the short answer so that you don't have to dig around too much. If you save it as a big number, the number representing the number of seconds that have passed in the current computing epoch. So the current computing epoch started in January 1st, 1970. So how many seconds have gone by since January 1st, 1970? In here, we had decided to store the date in the bowling scores object as a date object, and that's kind of convenient. And it's okay. We can recover from this because you can convert that date object to a big integer number, a long, that represents the number of seconds since the beginning of the epoch. So down here in the in the getters and setters, we're going to make another method called public long get date epoch. And instead of returning a date object, we're going to return get time. So here's the documentation for the get time method in the date class. It's a millisecond value, and the value is the number of milliseconds since January 1st, 1970. So we've almost got it right. We have the elapsed time since 1970, but we have it in milliseconds and not seconds. So I'm going to say get the time and divide it by 1,000. So that's the number of seconds instead of the number of milliseconds. Now another one, public void set date epoch, and it will take a long, which is in seconds, and we're going to say that the date object is a new date object that is that number of seconds, but it wants milliseconds, so we'll multiply it by 1,000. Okay, so this seems very, very, very awkward, and to me too. But what we've decided, and I'm comfortable with it now, that we're going to store in the database the date as a large integer number. That's how it wants it, and it will be a large integer number that represents the seconds since January 1st, 1970. So it's not hard to get. All APIs that deal with dates do it based on that time, the elapsed time since the beginning of the epoch. So our bowling scores object now has a way of getting the date out of the object in seconds and creating or putting the date object as expressed in seconds. And the rest of the code should just work. Okay, so we're going to go back here to this insert command. Well, when we were doing the building the content values in preparation for the insert command, and we're going to ask for that bowling scores object to give us the number of seconds, and that's what we'll store as the date. It's not that hard. It's just 2 more methods that does this conversion. The tricky part was making sure that I was dealing in seconds and not milliseconds, and there's a little bit of digging around. You think this video is long. It took me quite a while to really get that to do what I wanted it to do. So we have added a log there before the insert. Let's add a log after the insert. So after inserting a record, if we look at the bowling scores after we've inserted the record, we might see that the ID of the bowling scores is different now, because if the insert happens correctly, we should get the next integer number available to the database, and we put that into the bowling scores object. Oh, but we didn't print it out, did we? So in the toString method, let's add the ID of this bowling scores is, what did I call it? ID? That makes sense. Okay, so don't jam things up against each other. When this method gets called, and it gets called automatically, well, it gets called from the activity where the user enters the scores, we're going to go and put it into the database. Should we just run it and see if it works? I keep telling everyone, don't do that. You should run it in the debugger and see what happens. Where's my console? Well, let's look in the DDMS. Let's just save that default one. Okay, so here's the log down here. Before inserting a record, its ID was 0, June 9th, 3911. That's an interesting one. 3911. We're off by 1900 years. Well, the good news is that the insertion worked. If we insert another record, its ID is going to be record 2. So if you keep clicking this, you can see that we are adding records to the database. And that points out that this user interface has kind of a flaw, doesn't it? I don't want to save this set of games in the database 100 times. Well, there's 36 of them. When you save the data, the user interface should do something like put up a dialog and say your data was entered into the database, and probably clear these so that the user can't or won't push the save button again and accidentally enter the same data into the database multiple times. So there's a user interface flaw that we uncover, and you uncover those only as you go along. Only as you go along. So now we have to go and try and figure out, why is the year 3911? Well, okay, I have an answer to that. It's to this year bug. It's not a good answer, but it's an answer. So in the enter scores activity, this is where we get the data. On the save click handler, we make a date object out of the day, month, and year values that are stored in the class. So I've been tripping over this issue a few times, going between Gregorian calendar and date, and what I should have done is do a Shift F2 on the class and get the documentation for what you're working with, or on a method name. In that case, it was the name of the constructor for date. And the first thing that we find is that this constructor is deprecated. We should not have been using the date constructor that uses year, month, and day. And they added a class called Gregorian calendar, which is much nicer. It's so nice that it's really hard to use. So here's the kicker. If you enter 0, you get 1900. So our dates are off by 1900 years. What I was tempted to do is to just subtract 1900 from that, and that would be really an ugly solution. So I have yet another ugly solution. Instead of passing in year, month, and day to that, I'm going to make an instance of Gregorian calendar and pass in month, day, and year. Oops. Did I do it wrong? Yes. Darn it. Year, month, day. And that won't compile, because these are not compatible types. You can't assign a Gregorian calendar to an object of type date, but you can ask the Gregorian calendar object to convert itself into a date object. So this feels a little bit uncomfortable to me, but the whole date thing, manipulating of dates is kind of uncomfortable in this application. And if we have time later on, let's sit down and really make a plan for how we're going to handle dates throughout the application. We should have done it already. Okay, I should have done it already. I get very collective when there's a mistake made. So that will solve the off by 1900 bug, and it's not a very satisfying result either. But here it is. We can keep on working on the database stuff. We left this to do when the application starts. I'm in my Bowling Scores application. When the application starts, instead of making a new array list with nothing in it, we want to go and get the data out of the database. So we want to construct an array list of the history. And I will call this read bowling scores from the database. And it won't compile because we don't have such a method, so I'll create one. It's a helper method. That means it's private. And in here, I will take that line of code where we create the array list, move it down there, and now we're going to start reading the data out of the database. And we need something called a cursor. A cursor is like a pointer into a data set. So a bowling scores cursor, and import it so that it will compile. There we go. Now we need to make another one of these SQL queries. I'll just put some code in there and then we'll have a look at it. So I'm making this query from the bowling scores database. There's a method called query, and the first thing that I have to say is what table am I going to query out of this database? And I'm going to query the table bowling scores table. There's only one of them. And let me give you some room to see what's going on here. That doesn't compile because that constant is defined in the bowling scores database helper. So here's what I'm going to do. This is a nice, we could say bowling scores database helper dot bowling score table, or we could import the static import static will go into bowling scores database helper and get all of them. Okay, so it doesn't know where that is, and it is at com Valencia programmers dot. I left out one thing, my bowling scores. Okay, so what an import static does is it goes into this class, and you can use the wildcard. It will make all of the statics in there available to you. And then you don't have to prefix it with anything. We can just use bowling score table. And of course I spelled it wrong. Bowling scores table. Sorry about that. Now, so we're doing a query. This is like a select query, and we're going to specify what columns, and the columns are the data type that they want there is an array of strings. So what columns do I want out of the database? So I have to pass in a string array. I don't have one kicking around, so I'll make one here, a new string array. And then I will put braces here to initialize that array. And in there, I'm going to specify what columns I want. And I'm going to use those string constants that we defined over here in the helper. So the first field that I want is the record ID, and I'm doing copy paste now so that I won't spell things wrong. And I want the date and game 1, game 2, and game 3. Those are all string constants. So we have an array of strings as the second parameter, and there is no where clause in this query because we want all of them. We're not going to say select from bowling scores table these fields where something is true. We're just going to say we want all of them. So the rest of this, the selection and the selection arguments, the group by, and then having an order by. We could order by something. We could order by date. That would make sense to me. But the rest of them we're just going to fill in with null. So that was the columns, and then selection for nulls. And then put in the column that we want it sorted by. So order by date. And I can throw that away now. So there's a select query in SQLite using this, what it will return. So here's the database, and we are going to query the database with this select, and it's going to assign the result to this cursor. And the cursor, it's kind of like an iterator, if you know what that is. We will go through the records that it found in the database. So the first thing we'll do is say bowling scores cursor move to first. I'm not positive that that's necessary. I don't know if it would be at the first one anyway, but I'm going to do that. And we're going to build a bowling scores object. So we're going to get some data out of the database, and then we're going to build a bowling scores object out of that data. So I need a temporary bowling scores object here, and as soon as we get the object out of the database, then we'll add it to the array list. So what we're doing, keep your head at a high level too, where we are getting the data out of the database one record at a time, and we're going to build a bowling scores object and add it to the array list. So the array list will have the same data in it as the database. The very first time you can have a problem if there aren't any. So I'm going to say if the bowling scores cursor if it is after last, that means that there weren't any. And that probably won't happen, but it might. Someone might launch the application, not add any bowling scores, and then launch it again, and there would be an empty database there. So we don't want to do anything with an empty database. So I'm going to make a do-while loop. I know everyone is gasping. Do-while bowling scores cursor move to next. So we're going to go through the things that was returned, the things that were returned by the SQL query, and we're going to get the stuff out of it. So let's declare a long ID and use the bowling scores cursor. And we're going to call getLong and the column index. So it's the 0th column that has the ID in it. And then the date, and it's the date in seconds, so I'm going to call it date epic. The bowling scores cursor, getLong, and it's column 1. And then we have 3 ints. Game 1. And I'm hitting Control Space. Get int, and that would be column 2. Why don't we try and do that twice more? So we have retrieved the 5 items from that record into local variables, and now we can make a bowling score object. The ID, the date epic, game 1, game 2, game 3, and this won't compile. That's okay. In the array list, all bowling scores, we want to add the object that we just created. Okay, so we got the data out of the database. We made a temporary object and added that object to the array list. So now the array list is coincident. It is the same as the data in the database. But here's the problem. This constructor is not defined. So we never made a constructor for the bowling scores class that would take the ID and the date as a long and the 3 games. So let's go to the bowling scores class and fix that. We're going to add another constructor. I'll just copy that one because I can use part of it, but I need well, I don't want the date there. The ID and the date as a long. So there's nothing interesting about that one. We just assign the ID to the instance variable, but we can't assign this big number, which is in seconds, to the date object because its type is date. What we can do, if you remember, we made this method down here, which is kind of like a setter, set date epic, which takes seconds. So let's call that method. And now we have a constructor for the bowling scores class that we can use to put into the array list when we get the data out of the database. So let's go back here and see if we made any mistakes. Sometimes Eclipse gets confused and you have to save everything and then it will go and compile again. So we have a constructor here. So let's review what we did. In the application, when someone launches this application, we're going to set up the database, and that might mean create it from scratch if it's the first time, but more likely we will then go and read the scores from the database. We set up this cursor, which is really a SQL query, a select query, and we got the data into, well, you can kind of think of it as we got it into the cursor, or you can think of the cursor as the pointer to the data, and we're going to use that pointer to loop through all of the data that was retrieved, and each one will be added to our array list as we take the data out of the relational database and turn it into an object-oriented format. This is a fairly common thing to do in object-oriented programming. You have to store the data as a relational record, relational database record, and then go and get all the stuff out and reconstruct the objects. People compare this to driving home in your car, taking the car all apart, putting it in the garage, and then when you get up in the morning, you put the car together and drive to work. So it is awkward, but this is how it's done. And because we only have one table, it's not all that difficult. Let's do some logging here inside of this loop. Let's say we will log for the debugger and use the tag bowling database, and we will print out the data that we retrieve. We can just print the toString of that object. So we will be able to see the oh, it really wants a string object there, doesn't it? Okay, so we have to explicitly call toString. So I want to see the data coming out of the database and going into our array list. Here's something interesting. The application is still running, and I don't want to be confused about whether I'm running the old one or the new one. So in the DDMS, this is the process list, and we can go and stop that process. And I just realized that I forgot to do something. This is something that I do all the time. When you're done reading from this cursor, you have to close it. And if you don't, I'll spare us the debugging of that one. Because if you forget to close it, the whole thing just shuts down in an ugly way, and then you have to start setting breakpoints and walking through and trying to remember what you did wrong. And so that one's kind of ugly. So we were in DDMS, and we killed the process that was the old instance of our application running, and we can tell that we have some data in a database over here. And so when we run this, we should see in the log that it will start reading the data and start spitting those objects out as it creates them and adds them to the array list. And here it is. So what have we managed to do? We can get data into the database and we can get it out. Reading the bowling scores. This is a fairly complicated method that we're going to do when the application launches. So we'll go and we'll get the history of the bowling scores. And what else have we achieved? In the enter scores activity, we didn't have to change anything because we already, when we retrieve the valid scores from the user, we call the application's add bowling scores method. So this is kind of nice. We've separated the user interface activity from the from the application. So the add bowling scores method is now more elaborate. This is where we use the content values and we did an insert statement and inserted the data into the database. So here's something else that now that we have this perspective, that we have data going in and data coming out, when we got a new set of data from the user, we inserted it into the database and we added it into the array list. So during the running of the program, of the application, the database and the array list is always the same. So we added one to the database and we added it to the array list. So when the application shuts down, there isn't any issue of, well, we have to go and scramble to put everything in the array list into the database. It's always in sync. So we're at the place now where we can put data into the database from the user interface and we can get data back. And we have, I haven't been ignoring this. The application is not really useful until you can see the history. So getting the data in there is only part of it. We need to make another activity where the user can observe the data. So the history of the bowling scores. Remember this from maybe 4 videos ago? So that's where we have to go next. So the summary of what we did: SQLite. It's an open source, small, easy to use database that is in the Android SDK. Manipulation of dates is tricky. That's an understatement. We have built only a very small introduction to database on Android, and you can do a lot with a very small space. So getting the SQL commands to work the way that you want them to, you have some help for that with the content values class and the cursor and so on, but really that is tricky, getting all the commas and spaces in the right place so that it will execute, and you just have to be very, very careful and use this as an example. So we're getting there. We're getting there. It's starting to shape up, and we know that the interface needs a little polishing, maybe another dialogue to tell the user that they finished entering the data so they won't keep clicking save and mess up the database. That would be useful. And we need some corrections to the way but let's keep on track with the bigger things.